Let's try this one from the final exam review. This one tells me in 2005 there was a survey of 1,447 middle school students, and 7.8% had used tobacco before age 11. And then it was repeated in 2006 to 1,246, and 8.6% reported them. So the first thing I am going to do is verify that the conditions are met to even estimate the difference of two population proportions. And I need all of these numbers to be greater than or equal to 10. So N1P1 hat is going to be 1447 times 0.078. And you'll see that if you do that on the calculator, you'll get 113. And then I can either take 1447 times 1 minus 0.078, or I can take 1447 minus 113. All of these numbers end up being bigger than 10. For N2, I'll use the 1246 times 0.086. Then I'll take 1 minus 0.086 and multiply that by the 1246. And I'm rounding all these answers to the nearest whole. Then I'm asked to construct a 95% confidence interval estimate for the two population proportions. Notice I have this StatCrunch open from the previous example I did with the paired t-statistics, and I just left it open. StatCrunch isn't a choice here, so that's the best thing to do, is use an open window. I like to never close my StatCrunch window, and then I just keep using it. So I'm going to go to Proportion Stats to Sample. This is two samples because I have a sample in 2005 and a sample in 2006. And I don't have the data, I have summary data. And so I have the number of successes, that's 113. We calculated that already. That's the number in the whole sample times the success, and in this case a success is used tobacco. Remember, a success doesn't always need to be positive. The total number of observations was 1447. Then in 2006, I had 107 out of 1246. And so I got all these numbers from the totals and from the proportions. This is not a hypothesis test. This is asking me to construct a confidence interval, so I'm going to have to check the confidence interval box, verify the level is 95%, and then hit compute. When I do that, I see that I get rounded to 4 decimal places, 0.0286 and 0.0130. Since I have 0 in the middle there, because one of these numbers is negative and one of these numbers is positive, then I cannot say there's any difference. 0 exists there, and if those proportions subtracted equals 0, there's no difference in the proportions. And so even though 8.6 is truly a bigger number than 7.8, there's not enough statistical evidence to actually say there's really been a change.